If you're running real-time data pipelines in the cloud today, there's a good chance you're paying far more than you expect, even if everything looks architecturally correct. Kafka for streaming, a lakehouse for analytics, connectors to glue them together. This paper asks a very uncomfortable question. What if the cost problem isn't bad tuning, but the architecture itself? And what if streaming and analytics were never meant to be separate systems in the first place? Now, for prior context, over the last few years, lakehouse architectures built on formats like Iceberg and Delta Lake have become the backbone of enterprise analytics. At the same time, Kafka has become the default systems for real-time ingestion. In practice, though, these two worlds are usually stitched together with connectors. Data flows into Kafka, sits on broker disks, and is periodically copied into the lakehouse. This works, but it's expensive. Why? Well, because Kafka was designed for sub-100 millisecond latency with leader-based replication. Lakehouse ingestion, on the other hand, usually tolerates hundreds of milliseconds. That mismatch drives massive costs. Cross-availability, zone network traffic, over-provisioned brokers, disk replication, and entire fleets of connector jobs whose only purpose is moving data around. The result is multiple systems, multiple copies of data, and rising cloud bills. The central insight of this paper is surprisingly simple. If your destination is the lakehouse, why stream into Kafka first at all? Ursa is a Kafka-compatible leaderless Lakehouse-Native streaming engine. Instead of writing data to broker disks and then copying it, Ursa writes data directly to object storage in open table formats, while still exposing Kafka's streaming semantics. To make this work, Ursa changes three core assumptions. First, it removes leader-based replication. There are no partition leaders. Any broker can serve, produce, or fetch requests. Second, it decouples compute from storage. Brokers are stateless. Data lives in object storage and is tracked through a centralized metadata service. Third, it unifies stream and table semantics. The same data written for streaming consumption is compacted into Parquet and immediately queryable by Spark, Trino, or Flink, with no connectors and no extra copies. This isn't just a cleaner architecture, it has real measured impact. In the paper's evaluation, Ursa matches Kafka's throughput while reducing infrastructure costs by up to 10 times. These savings come from eliminating disk-based replication, removing connector fleets, avoiding across AZ traffic, and storing data once in a columnar format optimized for analytics. Importantly, Ursa still preserves Kafka's core guarantees, ordering, exactly one semantics, and durability. For enterprise teams, your analytics stack already lives in the lakehouse. Streaming analytics that duplicate storage and replication are increasingly hard to justify. And Ursa points toward a future where streaming and analytics could share the same data in the same storage with a single operational surface. This is quite an exciting paper, at least makes me get quite excited. And this is not just cheaper, it's simpler to reason about and operate. Check out the details in the paper in the description below, and thanks for watching.